Okay, that's case study for chapter 1. Chapter 1 is about computer programming. And we know this course is for introduction to computer science, right?
Mm-hmm.
So before that, let's talk about what is computer. So what's your thought about computer? What is really a computer?
Like there's a lot of different types. Like there's tiny ones like Raspberry Pi,
Yes.
which is like basically it just runs several commands up to like pretty complicated computers like the laptop I have that can run many different things.
And is cell phone a computer or not?
Mm-hmm.
How about pad? Pad is a computer.
A what?
A pad, P-A-D, iPad or something.
Oh yeah.
How about a PS4? Is a PS4 a computer?
Yes. It's just like a really expensive gaming computer.
And then what else you think can be a computer? A TV can be a computer or not?
Depends. Like if it's just for monitor purposes, then no. But like if it's like a smart TV and it has like built-in devices into it, like it can, like it doesn't need like a box at the bottom or something, then that's a computer.
How about a robot? Is a robot a computer or not?
Yeah.
Then what is actually define something we call it a computer? What is the real definition of we are trying to define as a computer?
I think it's like just something that can run commands for you, or like you can let it run commands.
Okay, then is an abacus a computer or not?
A what?
Abacus.
I don't know what that is.
There's abacus. Do you think abacus is a computer or not?
I don't know. Like, I don't think like maybe at a basic level, but like not the ones we count today.
Okay, and then that is something you may have question whether it's a computer or not.
Like it doesn't have any, it can't.
How about this? They have called this as a mechanical computer. A Babbage machine. This is actually built in the early 20th century. Is this a computer or not? This actually is defined as a computer. Okay. The Babbage machine actually is a computer. And actually in early 20th century, so the company called IBM, you know IBM, right?
Yeah.
IBM's name is actually called International Business Machinery, right? It's called International Business Machinery. And you know when does IBM actually founded?
No.
You know what company, what year this company is founded?
No.
So let's look at the Wikipedia. So this company founded 1911, and at that time there's no computer at all. So it's actually in at the beginning it's called Computing Temporary Recording Corporation, and then later it changed name to IBM. But at that time there is no electronic computer, but actually they have a mechanical computer. So it's actually the initial name is called Computing Tabulating Recording Company, and then they try to build a machine for business purpose. That's why the name become International Business Machine. That's called IBM. Okay, so the machine actually is mechanical. Initially, it's a mechanical. So whatever they are doing, they have the employee timekeeping stuff. They do weight scales. You know, that's the early day the product they have. You know, something like this, all kind of different things like to start an IBM. So computer as a name actually is something that it will help you to do calculation for some purpose. It doesn't mean that it had to be electronic. Okay, so the first one is mechanical, and then now we have the electronic computer, and actually in the future we will have quantum computer. You heard of the quantum computer?
Yeah.
So what is the difference between quantum computer and the computer we have right now?
I think isn't it that it skips some of the steps and makes it like smaller or easier, or I mean smaller or faster?
Kind of, but the real difference is actually the computer today. Original is like mechanical, so it's just like some wheel or something to help you to do calculation. So it's mechanical. And then around 1950s, so not mechanical is maybe early 1900 something. Okay. And then around 1950, 53, the first electronic computer came out. Okay. And then originally it's like vacuum tube. They have some light in there and then become transistor. Okay. And transistor being built into the integrated circuit. We call it IC. Okay. And now it's about time to become a quantum computer. So the difference between quantum computer and a normal integrated IC computer is the transistor one actually is built of some chemical devices. So there's an NPN, or they could be a PNP device.
What's that?
Okay. And you heard of the atom called silicon. Have you heard of this silicon?
Yes.
And silicon is for electronics at the outer layer.
Yeah.
And then you will create four bond, four bond inside. And that actually is this one is actually neutral, right? And if you have the doping for group 5 or group 3, you create N or create P. P is group 3 and N is actually group 5.
Oh wait, so is that like nitrogen and phosphorus?
No, not exactly. This one can be phosphorus, yes, but this one is actually not nitrogen. It's just for N. The name's name. It's positive and negative.
Oh wait, okay. Yeah,
so this one will have more electron. This one will have more hole. Okay, so when there's some electricity being applied to here, you create a channel, and then your signal goes through here and pass. And then if the voltage is low, if the low voltage is low, this one will be shut down. So you will perform just like a switch. You either turn on or turn off. So we call this semiconductor. And semiconductor is used for all the modern computers we have so far. And in the future, this is no longer small enough. So they start to talk about the next generation computer would be using quantum. And you took some chemistry before, right?
Yeah.
I heard that your mom said that you are going to take the chemistry by credit by exam, right?
Yeah.
Okay, whatever. This one actually is quantum, so if they have a few electron outside of a certain atom, and then you basically using the energy level jumping, and that you use that for computing. So you have the excited electron or dissipation for the energy, something like that, to control those electrons. If you are actually using the NPN type, it actually the electron is a few thousand Ks one, and if you are down to the quantum computer, it's only like 100 electron or something. Very tiny amount of electron will be used for computing. And you are using the excitation state back and forth to do computing. Is that okay?
So it uses less energy?
Less energy and device size is smaller.
Okay.
Okay, so that's what we call it a quantum computer. But computer can have different definition, and then actually everything can be a computer as long as you know how to compute. Okay. So let's do this. Wait, let me stop it. Okay, you probably don't hear it. Let me turn my speaker on, and because it will be the Zoom.us need this to be able to let you hear. Okay. Do you hear the sound?
Yeah.
Count on your fingers. It seems like a question with an obvious answer. After all, most of us have 10 fingers, or to be more precise, 8 fingers and 2 thumbs. This gives us a total of 10 digits on our 2 hands, which we use to count to 10. It's no coincidence that the 10 symbols we use in our modern numbering system are called.
So you use 10 fingers to count to 10. That's the normal idea you have, right? But the question is, how high can you count with your fingers? You have 10 fingers, right? What is a large number can you count by your fingers?
99.
99? Why?
Oh, because if you're doing like the, you said like the abacus, that'd be like 1, 2, 5.
Yes.
And then that's 90, and then 99.
Okay, you have a good way of doing it. But
Digits as well. But that's not the only way to count. In some places, it's customary to go up to 12 on just one hand. How? Well, each finger is divided into 3 sections, and we have a natural pointer to indicate each one, the thumb. That gives us an easy way to count to 12 on one hand. And if we want to count higher, we can use the digits on our other hand to keep track of each time we get to 12.
144.
Up to 5
right?
groups of 12,
12 by
or
12.
60.
Right?
Better yet, let's use the sections on the second hand to count 12 groups of 12, up to 144.
Yeah, then see.
That's a pretty big improvement, but we can go higher by finding more countable parts on each. For example, each finger has 3 sections and 3 creases, for a total of 6 things to count. Now we're up to 24 on each hand, and using our other hand to mark groups of 24 gets us all the way to 576. Can we go any higher? It looks like we've reached the limit of how many different finger parts we can count with any precision. So let's think of something different. One of our greatest mathematical inventions is the system of positional notation, where the placement of symbols allows for different magnitudes of value, as in the number 999. Even though the same symbol is used 3 times, each position indicates a different order of magnitude. So we can use positional value on our fingers to beat our previous record. Let's forget about finger sections for a moment and look at the simplest case of having just 2 options per finger, up and down. This won't allow us to represent powers of 10, but it's perfect for the counting system that uses powers of 2, otherwise known as binary. In binary, each position has double the value of the previous one. So we can assign our fingers values of 1, 2, 4, 8, all the way up to 512. And any positive integer up to a certain limit can be expressed as a sum of these numbers. For example, the number 7 is 4 plus 2 plus 1, so we can represent it by having just these 3 fingers raised. Meanwhile, 250 is 128 plus 64 plus 32 plus 16 plus 8 plus 2. How high can we go now? That would be the number with all 10 fingers raised, or 1023. Is it possible to go even higher? It depends on how dexterous you feel. If you can
a little bit right here, okay? The thing is like the first one we talk about the normal people counting. You have 10 fingers, so you use all those 10 fingers for 1 digit. one decimal value. So actually you count to 10, right? That's what you use that. And then the way you propose, actually you have the abacus way, so you can count to 99. Actually it's 100 number from 0 to 199 to 99. That actually use two hand as 2 digits, right? And then later he invented the 3-section way, and actually one hand is actually in radix 12, or we call it base 12. So one hand is actually a this, I don't know how to call it. It's actually 12 way of counting. So 2 of the 12 way radix. So you actually end up to be 144, right? And then later he invented the binary system. And in binary system, actually use the 10 finger, you can do 10 bits.
Yeah.
So each bit, each one is 0 or 1, that's 1 bit, 0 or 1, that's 1 bit, 0 or 1, that's a bit. Bit actually means binary digit. Okay, so the reason I want you to watch this video is to know what is bit and what is byte. What is actually byte? Bit is a binary digit, so it represented by this, right? And the byte is 8 bits, right?
Yeah.
So it represents a symbol something, right? And then with 10 bit, you have 10 fingers, so you have 10 bit. It will count from 0 to 1023. That actually is 2 to the power 10 minus 1. That actually use all every finger as 1. That come to that number. But this is not a limit that your 2 hand can count yet. So that's what continue to watch.
Bend each finger just halfway. That gives us 3 different states: down, half bent, and raised. Now we can count using a base 3 positional system. Up to 59,048. And if you can bend your fingers into 4 different states or more, you can get even higher. That limit is up to you and your own flexibility and ingenuity. Even with our fingers in just 2 possible states, we're already working pretty efficiently. In fact, our computers are based on the same principle. Each microchip consists of tiny electrical switches that can be either on or off, meaning that base 2 is the default way they represent numbers. And just as we can use this system to count past 1,000 using only our fingers, computers can perform billions of operations just by counting off ones and zeros.
Okay, good enough. Now, so by watching this video, actually the last one, he used 3 sections for each finger, and then it would actually end up to have what? 3 to the power 10 minus 1. So that number actually is what? That number actually is really huge, 59K plus, okay?
Yeah.
And then that actually is using so-called ternary, 3 ways, so it's a ternary bit, ternary digit, I'm sorry. So we can call it tit or something. There's actually no name for this, okay? We can call it tit or something, or some sort of the ternary digit. And that actually is a different way of counting. So your finger is the same, your hand is the same, your finger is the same. That is actually the hardware. Okay? And then the way you count is different. That is software. That's algorithm. That's the way of computing. Okay? And then if you use a DNA, you learn bio, right?
Yeah.
And DNA, how many the so-called what's the nucleic acid? Or how many type of them?
4.
You have the A, T, C, G, right? You have 4 different type of the. So actually, that it could be a quadro whatever bits, right? whatever is a name for that, right? That can be also be used for computing. That can be also be a kind of a hardware, right? So you might have already heard of the DNA computing. There is a certain way research field for DNA computing. Same thing, quantum computer, because your chemical, the atomic structure, the structure in such a way that the quantum actually is like an integer. Do you agree with that or not?
Yeah.
There's a certain integer level, and then that integer level can be used for computing. So that's why the quantum computer is there. So the thing that the first question I asked you, what can be a computer? The answer is everything can be a computer as long as you know how to use it. Right? Do you agree with this or not?
Yeah.
So that hardware is by the so-called computer engineer, the CE, computer engineer, to build a computer for people to use. Can be a DNA system, can be an abacus, can be a mechanical computer, can be a quantum computer by chemical engineers. And then computer science, so-called computer science or computer scientist, his job is different. We have computer engineer to build some sort of the hardware, right? And then this guy, computer engineer, scientist, his job is to do problem solving. And he is not using problem solving using pencil and pen. No, he's not doing that. Pencil and paper, no, he's not doing the pencil and paper calculation. He's actually trying to map the problem. His job is to map the problem onto the hardware. Just like we have the counting problem, we map into our finger. And the guy who can do the most efficient way, the fastest way to computer, that actually optimize the performance for the your system. So the computer science job is to solve problem, all kind of problem. Counting is only one of them, and to map that problem into the hardware you want to have.
Okay.
Okay, is that clear?
Yeah.
So that's the kind of thing. As an opening remark, I want you to learn is actually computer can be everything. Computer scientist's job is to find the problem, solve it, and then map onto the hardware and utilize the hardware to solve it faster. And even nowadays, you keep hearing the artificial intelligence, you keep hearing the machine learning, and those kind of things. They are just mapping the problem onto the computer and having the robot, having the chatbot, whatever the bot to solve the problem for human being. Right? And they all do the same thing, try to solve problems.
Yeah.
Okay, that's what computer is. And now we are trying to learn, computer programming, introduction to computer science, and Java. So we actually will cover Java from this aspect. So first things like we have a hardware, but the modern day hardware is just like this. You have the IC. So that IC actually is, you would have an integrated circuit, just like the picture you shown on the course. It's called integrated circuit. An integrated circuit has a bunch of the transistors, like the one I talk about. It actually is a chemical structure.
Yeah.
Electronic structure, whatever. Okay, and then that being put million of them or a billion of them onto a chip, and then that chip being soldered onto a certain motherboard that actually become your computer. And motherboard connected with the internet, with the Ethernet or your Wi-Fi or something, and also have a USB, and USB connected to your mouse, right? And connected to your keyboard, something like that. And then you have that connected to, you have the input, and then this guy also having the monitor. So you have the input from here, doing some computing, send to your monitor, or send to the internet and browse through the other machine at the remote site. Okay,
Yeah.
so that's the modern computing environment we have here. So here you see that the IC and memory board like that.
Yeah.
And now, let me ask you a question. Have you ever heard of the word kilo? What's kilo?
No. I don't know.
Kilo, K.
Oh, it's not like a.
It's 1,000.
Yeah, never
Right.
mind.
Have you ever heard of the word mega? How much is mega?
Is it like 10 to the power 4?
10 to the power 6, a million. Mega is a million, so you have to know about these numbers. How much is giga?
8. You said that just 8 by
3, 6, and then
9.
9. So the number you have, usually you have this, you read some number that they have comma. So the first comma is for kilo. Second comma is for mega. Third comma is for giga. Okay?
Okay.
And then what's the next one? 10 to the 12, what's the name?
Gigabyte.
What's your hard disk for your computer size? The size of your hard disk?
Tera?
Tera, yeah. The next one's tera. Okay.
Is that 12?
That's the 10 to the power 12. So now let's look at the website. Let me browse through. So you have, let's go giga, tera, micro. Okay, these different numbers. It should show up these different numbers. Let's not use this. It's too small. Let's use a metrical prefix. So right here, you have tera. That's 10 to the power 12. You
Yeah.
have giga. That's actually 10 to the power 9. Mega M. Actually, that's 10 to the power 6. Kilo 3. Hecto is 100. 2. Deca is 10, right? When do you see the word root DC? Where do you learn that? Decimal, right?
Yeah.
December, right?
10. Yeah.
How come December is 10 and then it's a 12, month is 12?
Because that used to be the 10th month.
And then why it become the 12th month?
Like 2 new months got introduced.
By who?
I don't know.
You don't know?
No.
Have you, did you, I know that your mom told me that you study Latin or something, right?
Yeah.
What's the number September? What's the word root for Sep?
7.
That is 7. What's the word October?
8.
Okay. What's the November?
It's Spanish.
9, right?
Yeah.
And then this month. So that's
10.
actually 7, 8, 9. And then something wrong before it, right?
Yeah.
Something wrong before that. That's actually happened on July and August.
I think. Yeah.
August, but it's actually for August. July is for Caesars. So actually it says so actually it's because the two kings put their name into the months.
Oh, okay.
Okay, these two kings, they are selfish. They put into the calendar, and then everything just shift by 2. Okay, originally they are 10 months, and then these two guys, they feel that they are so great, so they just move it. Okay, there's nothing wrong with the word root. Okay, but set still be 7. Okay, but someone who just be selfish and then insert their name into the system. So when you see this deca or deci, that actually is the decimal system. So it's actually 10. Centi is for 100. Century, right? Medium, micro, narrow, pico, femto, alto. So probably from tera to down to femto. These are the number at least you need to know. Okay, some of them probably you see it in the chemistry already. Okay, some of them you probably see in the chemistry, but these are the number you need to remember. Especially for computer, you need to know from kilo to tera. That's usually used. And then why kilo is so popular in computer and mega is so popular in computer? That's because we use the binary system. We use the binary system, right? So if we have 10 to the power 10 is how much?
That's the number we just did. It's the other number we did. I think it was like two.
That's actually 1,034. So that one actually close to 1K.
Oh, okay.
Is that okay?
Yeah.
That's close to 1K. So then 10 to the power 20, that's 1K times 1K. That's actually 1 mega. And then 10 to the power 30, that's actually 1 giga. 10 to the power 40, that's actually tera. Yeah. So actually, the thing like we talk about something is terabyte. Actually, it's not exactly what 10 to the power 12. It's not exactly that. It actually means what? 2 to the power 40. That is the amount of number of bits or bytes in your system. So if you check your hard disk, say, it is exactly 1 terabyte. So for example, if I borrow my own computer, and then say, let me see on my C drive, or let me see, actually browse this computer. There's a certain drive, right? It's actually 576 gigabyte of 931 gigabyte. It actually is not exactly 1 tera, but when they sell me, they actually claim that it's actually 1 tera, but actually it is not. This one is 1.8 terabyte. When they sell me, they told me that it's actually 2 terabyte. Okay, so the number is not very exact. Sometimes you have to check how much it really is. Okay, so that's about the computer part. And the next one is actually what is programming. Okay. And programming actually is just like last time I showed you to write a simple program. You have some input, you have some output. Input can be from your keyboard or your mouse, right? Even you play a game, the mouse click, and then go into your program, and then you change the status on the computer, and then you show on your monitor or print out as a paper. Those are outputs. And then the input like keyboard, mouse. Okay, can you tell me one more input device for your computer? Not keyboard and mouse. Camera, yes.
Camera, yeah.
And then what is the output? One more output, not printer, not monitor.
Going online.
Going online actually is in and out. It can be input, can be output. Okay.
Okay.
Look at yourself. What do you have right now?
Oh, I can see myself.
You have the ear plug, right?
Oh.
That is actually an output device. Not connected to USB port, and actually that is a output device. Is that okay?
Yeah.
So that's the input and output. And then in the middle, we do some computing, right? We actually map the problem to our program. So there's some math or some calculation or some computing need to be done, right? And then there's a certain decision need to be done. You either continue to count or not continue to count. Those are called decisions. And then decisions sometimes also be simplified as if something happened, then I do something else, I do something else. Right? So it's actually making some route, go here or go here, and then eventually meet together. So this is the decision box. Right? That is actually a decision box. Is that okay?
Yeah, so
That's a decision box. So, but sometimes there's a multiple way of making decision as well. Here, that's a decision. What is repetition?
Like
In our computers, we have decision, we have repetition. What is repetition?
it's just something that just happens again and again.
So something like, okay, you do something and then you go back and continue to do until you decided to quit, right? So that will loop back forward. So actually sometimes it's also called loop, right?
Mm-hmm.
And these are just basic program structure, have decision and repetition. There's one more. There's one more called recursive recursion. Have you heard of this word?
I've heard of it. I'm not sure what it means. I forgot.
Recursion is something like this. I have a sequence 1, 2, 3, 4, 5, whatever, right?
Mm-hmm.
I can write it down as a n equals n, right?
Mm-hmm.
But I can also write it down as a n equals a n minus 1 plus 1.
Mm-hmm.
This one is called recursive structure. That one is called explicit formula.
Mm-hmm.
This one is called recursive formula. Is that okay?
Yeah.
And the recursive means I have a problem, I can solve it by a smaller one, and then keep going back until you have the base case condition A1 equals 1.
Okay.
That's called base condition. With the base condition, with the recursive structure, you can define a whole sequence. That's called recursion. So program structure mainly has 3 types: decision, repetition, and the recursion. Is that okay?
Yeah.
No matter what program you basic like that. The next one is this so-called Hello World program. That's the first program. And the good thing about this website, this Sync Java 2 website, the Twitter.io website, is actually, you can try. So here you have a Hello World, you try it and run it. Okay, so actually it run and they say Hello World. So right here, I can actually try my own program as well. And here, something like this, okay? So actually you will run and get the result. Is that okay?
Yeah.
This actually you can keep trying and then you can share it to the Facebook, email if you finish it. Okay? You can try that. Okay, so that's something you can try. And then this is a simple program. A simple program content of a class and a main function. What is the main function?
What?
Last time, actually Friday, I'm sorry.
Oh, I didn't know why.
It's an entrance point for the program. Did I told you that?
No.
Or probably you forget. Actually, I told you. It's
No, we didn't.
We actually run some program last time, right?
We ran Hello World, but I asked
Yeah,
what
but
it meant.
yeah, okay. But I did mention that it's an entrance point for it. Okay, but it's okay. Now let's continue. Actually, each one of it is called a statement. Statement is just like a sentence in your English writing, right? It's like a statement. And then the main is a function. It's a function. It's like a paragraph or something. And then class is like an article. Is that okay? Okay, so that a class contains several functions, and each function has several statements. And then this print statement is a very simple statement. You have system.out.println, and then you will print out something for you. So that is a very simple program. Just print out 2 lines of the message. Okay, that's actually called Hello World. And then that is called a method. A method is a named sequence of statements. So you put several statements into your main function, and then actually that is a function. Actually, is a function. Method is a function. So you put several function statement into there to perform a certain task for you. Okay, so right here it's actually a method, and the class is a collection of methods. So method you can think of is like a paragraph, and the class is like an article. Okay, so you actually so this article only has one paragraph, and that paragraph has 2 sentences, something like that. So that's a class is like an article, and function or method is like a paragraph, and then each of the statement is like a sentence. Okay, and then each sentence or each statement finish with the semicolon. Okay, and it's also case sensitive. So if I put something like lowercase s, it will not work. It will not work. You will have error. So you have to follow a certain way of writing it. That's called syntax or grammar. Okay, so a program has the component, structural component, and also need to follow the syntax or grammar for the language defined by language. And the language we are talking about is what? It's Java here. Okay, but there are tons of the language we mentioned last time, right?
Yeah.
And there are 3 types of translation. What are the 3 types? Still remember that? Interpretation, compilation, and
then
hybrid. Right?
Yeah.
3 types, and that represents 3 different language. Okay. And then I talk about this double slash.
Yeah.
That we talk about, and then slash star star and slash star. Okay. And then we compile the Java program as a high-level language, and I show you the ranking for different language, right? And then I talk about the low-level language can be machine language that's 0, 1, or those hexadecimal value program. And then there's something between high-level language and low-level language that's called assembly. And assembly actually has a one-to-one mapping to the machine code, right? We talk about this. And then it's much higher, easier to program in high-level language than low-level language.
Yeah.
And high-level language are portable. That means you can send the text file and then you can run on a different computer. And then there are 2 types of the compilation. One's interpreter, one is compiler. And the program you write, that Java file is called source code. And then something to be run on the computer is called objective code or executable code. Okay? And then Java doesn't compile right to the object code. It actually generates something in between called bytecode. And that bytecode being interpreted by Java virtual machine. That make Java a hybrid system, and also make Java a language that actually is platform independent. The Java code will run on both Macintosh computer or Linux computer or Windows system.
Yeah.
Right? We talk about that. And then 1.5 is to display 2 messages. This one, instead of I continue to do programming, I will stop sharing and you share your system. You bring up your project. Is that okay?
Okay. Do you want me to go to the trinket.com also?
What? You don't need that. You just bring up your project first, and I guide you to do the first program by yourself. Is that okay?
The BlueJ?
Yeah, bring up project. Is that okay?
Okay, let me get BlueJ first. I have it downloaded.
Oh, you haven't downloaded.
I mean, I have it downloaded. I just needed to launch it.
Oh, okay. You need to launch it. Okay.
Yeah.
Now I stop sharing and you share your screen. Is that okay?
Yeah. Give me a sec. It's loading.
Okay.
Share screen.
Yeah, share screen.
Desktop. No thanks. Okay, here.
Yeah. Now you new a project.
Project.
New project, and then don't put it here. Put on somewhere you eventually will collect your program. You can choose. You can use choose. And then put on some, no, don't put on the document. You click this PC.
Okay.
You click this PC, okay?
Laptop?
And then you have different folder, right?
Yeah.
And click the C drive.
Okay.
And then right here, can you create a new folder? Could you create a new folder and name the Ethan Wu or something? That's your project directory. So you can collect all of your Java code over here. Type your name, that would be the best. You will remember that's your program. Yeah. And then double click on it. And then no, not selected, not yet, choose, okay. And then right here, click another level of the folder. Now you put the Java programming. Actually, this should be a folder for you to collect whatever available for this course. Is that okay?
Yeah.
So call a Java programming. That's fine. Okay, and then double click on it.
Okay.
Finish and double click on it, and then create another level. No, not yet. This one called Boojay. Okay, and again, double click on it.
Okay.
And then this one actually, this time select folder. This time you click the select folder. So you have a course and then you have the Boojay, right? This time select folder. And then at the right box, you put in your name. Now you type chapter 1. So your Boojay will have chapter 1, chapter 2, chapter 3, whatever, right?
Okay, yeah.
And not under the Java programming file. No space.
Oh, okay.
Yeah, you can put a space, but I prefer not to have space because later it will be better. And then click OK.
Okay. Okay. Okay.
Okay, good. Now you actually click the new class. And then here you type hello world. Okay, I'll let you create a hello world by yourself. No, this time no space. I told you no space. Try not to have space in the Boojay environment. Click OK. Okay, double click it. Okay, then after the hello world and the curly brace, those white and yellow part, just delete them.
This?
The whole thing after the hello world and curly brace. All of them. Delete all of them. Not yet. All of them after the curly brace. Oh, no. You delete too much. No. Yeah. I told you hello world and below.
So that?
Yeah, from there to the end, almost there. Okay, not good enough. Those are okay. Put it there.
So
you do public static void main.
Dot static?
Static. No dot. Public static void VOID space main MAIN parentheses. Put 2 parentheses.
Wait, can you give me a second?
Yeah.
Okay, sorry.
Yeah, no problem. You type a string, string, yeah, and type str, capital S, please. Bracket, left, right, bracket. After the bracket, not this one.
So like that?
No, the string, after string. After string.
Oh, after string?
Yeah, after string.
Wait, isn't that?
String. No, that one is fine. Don't do anything there.
Okay.
And then after string, string, after the string. No, not there. Yeah, inside. Yeah, there. You put left, right brackets.
Oh, you put the brackets here?
Brackets there, yeah. No, not this curly brace. The bracket.
Oh.
The bracket, the square type. Yeah, this one. Space. No, not inside, outside. Yeah, there. And then you put ARGS. No, lowercase ARGS. Okay, now good. Go to after the first curly brace. Return. Keep pushing down. Okay, good enough. And then the last one, the last green curly brace.
Yeah.
Can you move it to be in parallel with the public class hello world? The last one. Not that one. The last one. The last one. Yeah, push it to the first line. Okay, good. No. Yeah, there.
Yeah.
Stop there. Okay. Now here you type capital S Y S T E M dot out dot print line left right parenthesis semicolon and then semicolon. Yes, and inside there double quote hello world. Yeah, okay. Now you hit compile. Compile, yes, hit compile and then go to the orange box outside. Orange box.
There's like this thing right here, up here on the top.
Yeah, no, I mean the orange window.
No, I mean like how do you make it smaller? Actually, no, never mind, got it.
You want to make the font smaller or what?
No, there was like this, there was like the settings on the zoom settings.
You want
yeah, I got it, it's fine. No, the zoom settings were like blocking up here. Wait, so what?
Yeah, okay. I think it's just leave it there. You minimize it. That's fine.
This?
Yeah, you minimize it, and actually now you right mouse click, and then keep the void main. Yes. Go.
Okay.
Okay, good enough. Now you go to your browser. Have a new tab. Now you try the Trinter one. So you actually go to Google. Go to Google search. Yeah, and then you actually type Trinter. No, TRINKTER. And then space. Sync Java. JAVA space. Second, that's 2E. 2E is good. 2E. Second edition. No, 2. Number 2. Yeah. Number 2 and E. Yeah, good enough. Hit return. Okay, so the second one. Yeah, that's the course address. Okay. So probably you need to bookmark this one. That would, okay, you actually have that bookmark this one. Hit a star, yes. And then, yeah, that's good enough. Now, actually, you go to chapter 1. Pull down. You finish the hello world, right? Now I want you to do, in class, do the next one. Display new to message hello to. Okay? Now, actually, in your hello, try to modify as it is. You're the hello world, right? Now, add that how are you in there.
Okay.
In your own Java. No, not in there. Yeah, in your own Java. Have another sentence. Have another statement. Yes, try this. System.out.print line. Left right parenthesis, semicolon, go back, double quote. Yeah, okay. And then how are you? Yeah. Remember to have pairs together, okay? Not because that will save you time, because you will have the parentheses matched together or you have double quote matched together. Is that okay?
Yeah.
Otherwise, you open the left one, but sometimes you forget to close the right one, okay?
Yeah.
Then hit compile again and minimize your program. Yeah, and then go to your Blue Jay, the orange box one. Left side, orange box one. Yeah. Hit right main, and run. So now you are able to do keep programming, right?
Yeah.
But how comes that there are two hello world?
Did I not clear it or something?
Yeah, they are not clear. So now you go back to your hello world. Go back to your hello world, and then before the first statement, before the hello world statement, it return yes, and then system.out.print line, and then delete the ln. Delete the ln, yeah, parenthesis, semicolon. Is that semicolon or colon?
Oh wait, semicolon?
Yeah. Yeah, okay. A semicolon. No, semicolon. It's not colon.
Wait, that would.
Okay, and then go back to print. Go back to print. Yeah, inside there, double quote, double quote. Double quote.
The wrong one, sorry.
And then inside the double quote, backslash. No, this is forward slash. Backward slash is like the other way. Yeah. And then F. Lowercase f. That's it. Hit compile.
Wait, so what is that?
Okay, you follow me. You just hit compile.
Yeah, I did.
And then go back to orange box. Go back to orange box. Right click, main, go. Now, what that means? It actually clean up the scene, right?
Mm-hmm.
Okay, go back to your hello world. Add the third line to see if it actually cleaned up the old stuff. Now you add another line. Copy. You can just do copy.
Okay.
You can just do copy, yeah, and paste. And then you change the content there. Not how are you? You change something else, whatever you want. File or something, yeah. And then hit compile and then go back to hit compile and go back to run again. Okay, so what did you learn so far? You learned how to write your first program, right? You learn to put multiple statements. You learn to clean up the page. Okay?
But, yeah.
And then that's what you learned so far. You try to have the first program. Now go back to your printer page. So that you can hit the run for the hello to, but that actually is simple. You already done it. Okay, now go to the hello, the goodbye. Okay, what do they want you to do? The goodbye actually. Okay, remember here you had a print and print line, right? Print ln.
Yeah.
Print ln actually has the change line. But try hit the run for this goodbye. What happens? Goodbye actually is in the same line as crew war. So actually, the goodbye actually doesn't create a new line after you finish.
Wait, but if you like write this
Yeah.
in the next line, will it go right in the next line?
It will write in the next line, yes.
Okay, yeah.
So if you put that's don't do this. That put the first one goodbye with ln. See what happens.
And why does it automatically clear it?
Yeah.
Oh, yeah.
Okay, this one clear it because of printer editor, not because of the program.
Okay.
Okay, because the right hand side, the printer itself will actually clean it, right?
But I have a question about that BlueJ thing.
Yes.
Isn't this just supposed to print this thing, like \F?
No, it actually interpreted in a certain way. You actually pull down 1.6 in the printer. Continue to pull down, right? And then pull down. Continue. That's wait. Too far. Go back. Go up to 1.7. But wait, stop there. 1.7. Read for me. What's the title?
Escape sequences.
Yeah, the backslash is an escape sequence.
Oh, okay.
So continue to pull down until there is a table. Okay, stop there. Backslash n is new line, backslash T is tab, backslash double quote is called printing a single double quote, and then backslash two backslash will print one backslash. Okay, and this one backslash F actually means to print a new page. F is actually called form, FORM. So backslash F is new page. Is that okay?
Yeah.
Can you do you have a notebook or something? Write down those kind of things I actually told you.
Like,
or backslash F is like new page. Do you have some sort of notebook or you?
Like notebook or notepad?
Notebook, or you can save on your directory as a file, or you can pull up Notepad. That's fine. Yeah. So you can try to write some note for chapter 1, something like that. You say chapter 1 note. Yeah. And then you say like x1, number 1. Yeah. And then say like backslash F means new form, new page, yes. That's something you not want to know. Backslash is not forward. This one's forward slash. This one's forward slash. Backslash. Yeah.
Clear space?
Yeah, clear page, not space. It's a whole page, right?
Yeah.
Yeah, and then the second one, and then second one you say backslash is for escape sequence. Escape sequence. Well, what does the escape sequence mean?
That is it. Just like it's part of the system.
It actually performs a certain function for you, right?
Yeah.
It performs some sort of a function for you, and it actually doesn't follow the original strings requirement, right?
Mm-hmm.
Okay, and then put number 3. Yeah, print and printf. What's print and print ln? What's the difference between them? Print is for printing without creating a new line, and print ln will create a new line, right?
Print is for creating without a new line.
Yeah. And print ln is printing with creating a new line. Okay. Now you hit File and save this to your directory. Save as, and then go to this PC, right? And C drive, and then your Ethan directory, Java programming. Under here, you create a new directory called notes or something. And inside the notes, create another directory, and then chapter 1. Okay, and then inside there, here you can write whatever name you want to have for the file name. Okay, write whatever, yeah. Commands, yeah, it's good. Okay, and save it. Is that okay? Then you can take notes and then organize it together. So right here we see you have backslash n and backslash t and backslash double quote. You go up to your escape sequence. No, stop there. Right? Go to the escape sequence. Run that hello 3 program. What do you see there?
It just kind of...
The backslash n will change it for a new line, right?
Yeah.
And then after the backslash n, you actually, you create a new line. Create a new line and then copy the system.out.print. Yeah, and then put the parentheses, yeah, and then put double quote. Now you type 1 backslash t backslash 2 /t, and then 3, and /n, and hit run. What happened to this? You have 1, and then you
tab
by A spaces, and then you tab print 2, and then create by A spaces, and then you print 3, and then you change it for a new line.
I don't. Oh yeah.
Is that okay?
Yeah.
And then the last /n is equivalent to you have the print ln.
Yeah.
Right? Is that okay?
Yeah.
So this is called escape sequence.
So.
Okay. This is called a escape sequence, and it is used to format one way of formatting your text. So if you want to take notes, you take notes. And in fact, you already has the under your menu already have the file open.
Wait, no, that was a different one.
Oh, okay.
Escape.
Yeah. Okay.
Sequences. You can do space there, right?
Yeah. For file name, yes. But usually I don't like that because sometimes you will create trouble for yourself.
Oh, okay then.
Okay. Especially when you go into the Windows and then try to open the file. And file name with space sometimes create trouble. And you need to write down your /t, right? /t.
Why do you want to do this instead of just typing that out?
Save time, maybe. You know, if you hit the word program, you have the word program. Actually, the word program, you can still hit a tab key, right? On your keyboard, you have a tab key, right? So you edit, actually, they will save /t for you in the program.
Wait, what?
When you do this, actually, if you right here, if you hit the tab key on your keyboard, right?
Yeah.
You will go a few space, right? And that will be faster for you actually, and that will also help to keep the same distance for different words. So that helps you to align something. You know what I'm saying?
Yeah.
That help you to align for something. So save this one, and then save this one. Save this file, and then go to what? Go to your browser. Go to your browser. Save. Yeah. Okay. Click it and save. Okay. Replace it. Now go to your browser. Go to your browser. Yeah, and then now hit Google. Okay. You search for ASCII. ASCII. ASCII capital. ASCII R. That's fine. ART. Yeah. Hit it. And then you go to second one, the Chris.com. Chris.com.
This one?
Yeah. The second one, Chris.com. Okay.
Oh.
Okay. You will have the Christopher, whatever it is. Okay. On the left hand side, you have animal, book, whatever. You hit the one you like. On the left hand side, you have different category, right? Collection. Hit someone you like. Yeah. Hit someone you like.
Pick an animal.
Pick whatever animal you like. Just take some, whatever you like. Try hit something. Okay, fish. Hit it. This is too complicated. Try some simpler one. I want you to tune it on your Java program. So try someone smaller and easier. Don't try something too big, too difficult. Just hit something you will see. You see something smaller.
This is just birds.
Try something, whatever. You just hit. If you don't see it, you never know how far it is. Try something. Oh, these are also very difficult. Try something easier.
But I think if you scroll down.
Yeah.
Maybe like these are easier.
All of them are difficult.
Oh,
No, you
okay.
try book or something. Try something easier. Let me see. Okay, the smallest frog. Yeah, copy that one. You missed something. Copy that one. Copy. Wait, did you copy or no?
Yeah, I copied.
Okay, and then go back to your Java. New a class. New class.
Okay.
New class. This time call it frog. Okay. Hit OK, and inside there, go into frog. Under the first line.
Mm-hmm.
No, first line. Hit return. Hit return up to the first line. No, not there. Inside the class. Yeah. Inside the class. Up to the frog. Up to the curly brace. Yeah. Before before that command line. The line before it. No, don't hit that. Yeah, the line before it. Yeah. Put paste. This is a frog layer. Okay, now stop there. And you delete delete it, keep it moving. Okay, stop. Okay, now you delete the instance available, those kind of things to the end. Delete the whole thing. No, delete to the end of the program. Keep the last curly brace. Yeah. Now stop there, stop right there. Okay. Now you at the beginning of your frog eye. Beginning of the frog eye, at the beginning of that line. One more. You have one more space. Right there, type capital S system.out.print L as parenthesis double quote. No. Just one parenthesis double quote. To the end of the line. Oh, no. You don't need that. To the end of the line. To the end of the line. No, the line, not line.
Oh, okay.
And then double quote, parenthesis, and then semicolon. And go back to the print. I like the print line and not the print. No, print line. LN. Okay. Then you actually copy from system.out.print to the, including the, stop. Including the parentheses, double quote, yes. Copy to the first place or the second line, paste. No, don't do that. Next one, finish all the print, paste. Yeah, and then go to the next line, paste. Keep finishing the left side first. Yeah, something like that. Okay, and then go back to copy the double quote, parenthesis, and semicolon. No, don't type. You just copy and paste. Yeah, that would be faster.
It won't let me.
You will let you. Don't you just click? Yeah, it's okay. Don't be scared. The gray one doesn't take effect. Okay. Save. Compile is okay. Compile, but don't run. Okay, something wrong with, you don't have the public static, but it's okay. Now, the next thing you will do is that move your cursor to the public class frog. Put it there, put the cursor there. Now you keep Control F. Control F.
Yeah.
Right here, you hit backslash. Hit the backslash. Yeah, and then we keep replace. Replace, yeah, hit replace.
I don't see a
replace on the right hand side. On the right hand side, the same line of the find. Replace.
Oh, there. I can't see it. It's on the bottom. Like there's something blocking it.
No, it's not blocking you. You have the.
No, I mean like there's like the setting configuration. Do you want me to send you a screenshot? Oh, whatever. I found it.
Where is blocking?
Here, I'll just take out.
Yeah, but I'm not trying. You have the find, right?
I got it here.
Yeah, replace. And then now, no. Go to the replace box.
Oh, dang it. I'm gonna move it back up. How do you move this up?
No, you go to
Okay, there, I got it.
Yeah. Go to the
Okay.
replace box. No, not the second one. Hit double two backslash.
Backslash?
Backslash, yes. And then hit once now. And then hit next. Next. N-E-X-T.
Oh wait.
No. You actually you have one more. Yeah. Yeah, actually now you kind of need to hit replace now. Hit replace again. And then double two backslash. And then how comes and then actually hit next. Hit once. Hit next. Hit next. Hit once. Hit next. Hit once. Hit next. Hit once. Hit next. Hit once. Hit
I think
next.
we forgot one.
Well, don't care about it. It keep going.
That's it.
Hit next. Hit next. Hit once. Okay. Save. Compile. And then you need to add the public static void main now.
Was it like public?
Static, lowercase static, void, lowercase void, space main, M-A-I-N. And then parentheses, no, you hit the wrong thing. Parentheses. And then inside there type string, capital string. And the brackets, and then space. And then space. No, after the brackets. No, after the bracket, not after the, ARGS. After the parentheses, you type a curly brace. No, one, just one. And then after the last line of the your frog print,
Here?
it return. Add another brace. Yeah, that's it. Compile and run. And then hit run. Yeah, print up and then run the frog. Okay. Okay. Does the frog look okay or not?
Yeah.
Yeah. So the reason why I stop you not to check whether you miss some of backslash or not is because you actually can come back to your execution result to check it.
Mm-hmm.
Otherwise, you have so many of them. You don't know. You really don't know which one you have extra or you forget something you can already do. You know what I'm saying?
Yeah. So, but if you want to
now go back to your frog and then add that backslash f things. Right? You don't want that to actually bother you, right? So no. Wait. I actually want you to push everything back. No. You actually add the system dot. I want you to type a new line. Yeah, type there system dot out dot print line. Print, not print line.
Print.
Yeah,
oh yeah.
Yeah, you don't want to change your name. And then backslash f, right? And then push whatever your system dot out to be aligned with that system. Yes. Just tap yes. So tap actually faster, right?
Yeah.
And then the second last curly brace. Second last curly brace.
Mm-hmm.
Push it one. Okay, yeah. Now it align with the public static things, right?
Yeah.
So as you can see, if you actually align them together in the right way, your main program actually now is in the yellow box.
Yeah.
Your main class actually right now is in green box.
Can you have multiple classes in a program?
Yes, but that's not a good practice.
Oh.
That's okay, but that's not a good practice. Now change the name. Change the author name to your name. Change the author name to your name. Yes. Okay, space U. Yes. And then change the version of date. Put the date, your date. June 4th, yeah, 2018. And then now you compile. You compile again. Yes, okay. Compile and run. And bring up your box. Yeah, run it. Okay, hit okay. You have a frog now, right? And if you like, you can go back and change the print to print line for the \f. Look like you want to have some space before the frog, right?
Okay.
So that new line actually is fine, right? Okay.
But won't that just clear the line? Oh wait, never mind. Yeah.
It's okay. And then you can also do this. After the \f, you can also do \n. Let's try this. Let's try this. Let's try this. Yeah, try the \n things, right? And compile.
Yeah. You don't need a space, right?
A space will be extra one space, you know. If you put a space, that's an extra one space. So it doesn't matter actually.
Okay.
You know what I'm saying?
Yeah.
It's one extra space, but it doesn't matter actually. Hit compile, you compile. When you have a slash things, that actually a uncompiled file.
Oh.
So now you hit things.
So there's a space now.
Yeah, now it's a space now. Now you go back to your frog. Go back to your frog. Go frog program, yeah. Now at each line, beginning of each line, please type a \t now. No, not there. Not in the double quote. Yeah, inside the double quote. \t, and then you copy that for each line. I just want to demo that actually your frog got moved to the right by the tab. Is that okay?
Yeah.
And then run it.
So it's
okay.
Yeah.
Is that okay?
Yeah.
So that actually is something interesting to work on. Now close it. Close your output. Yeah. What's your question?
Can you do it for like two? If you like wanted 2 lines down.
Yeah, you can just
like 2 and or just.
No, that won't work. You need to
do it twice.
\n, something like that.
Oh, okay.
Okay. Now let's do this. Now actually you hit the source code. Remember that the documentation page?
This
hit
one?
The source code. No, the BlueJ source code on the right upper corner. Right upper corner, there's a source code, right?
Source code.
Yeah, and then documentation. Try to create your frog box, right?
Yeah.
These things and then your name, whatever, that's your documentation page. Now move back to your source code, right? Now next thing you go open your BlueJ origin box window now. Yeah, now double click on the text file.
Yes.
No, the text file, text.
Oh, okay.
There's a text file on the right hand side, right here, right? Project name, type what? Chapter 1 or something in that front. You have to actually, this is a whole, for the whole chapter 1. Yeah. Chapter 1, computer programming. Okay. And the purpose of the project type, whatever, like basic practice of programs. Practice, not product. Practice.
What?
Practice. Pratice.
Oh.
You have practice. You miss a C or something, right? Practice, right? Practice.
Oh. Programming?
Yeah. Okay, and the version date is the today's date. Okay, also type your name. Okay, stop there. To the end of the user instruction, hit return. Hit return, one more return. And then you type minus sign, minus. Keep doing that, Keep doing that. Keep doing. For the whole line. Yeah. Okay. One more. Okay. Stop. Just like the one above, right? And then hit return. Now you type s lowercase s plus and column. Okay, column, not semicolon, column. Yeah, and then space. Okay, type what you learned from here, from chapter 1.
Was it called escape?
Yeah, something you learn. So this one is called Readme File. It's used to take notes for your project.
Escape sequence.
Yeah, it's a sequence. This one is to help you to organize the project, because this is one text file under the same project directory. So you say you learn project sequence and then hit return and then space. No. On the same line, on that line, hit space, so that it aligns with the escape sequence. And then here you say design a ASCII R program.
SKR?
An ASCII card. N. No. N was the A. Yeah. ASCII ASCII.
Oh, ASCII.
Is
that okay?
I will explain this later. Just type this. ASCII art, ART program, right?
Yeah.
And capital frog. Yeah, something like that. And then hit return.
Do I need?
Yeah, whatever. And then hit return. And then go to the beginning of the line. Now you type S minus.
What does that mean?
Okay, S plus is something you learn, right? And S minus is something you actually don't know or struggle. Okay? So right here, space. Let's assume that you struggle on this program. So here you type like I struggle with the formatting of the file, something like that.
Yeah.
Just keep note like that. I mean, yeah. That later you know that this is something you need to improve. Is that okay?
Yeah, formatting of.
Hit return.
From here?
No, the up to the S minus.
Wait, is there supposed to be 2 spaces here?
Yeah, whatever. You need to align it, yeah. Okay, then after the file, hit return. Type the minus sign now.
Minus?
Yeah, keep doing that, just like a separator for the lines. Yeah, until it align with the last one. Stop there. One more. Hit return. And then, over there, type in the future.
In the
future. A future. I mean, FU. Yeah, semicolon. Column. I'm sorry. After the inner futures column.
Colon.
No comma. Don't do comma. Yeah. Okay. The S plus is something you learn or you are good at. Or this one is you achieve something, right? S minus is something you struggle or something you need to improve, right? And then in the future is something you want to do in the future. What is something you want to improve on? So right here, probably you write down something like, okay, I'm going to do more ASCII art design. Something like that. Okay. This is fake, just do, yeah. You know what I'm saying? So then you actually have a organized description of what I achieved here, what I still need to improve, and what I'm going to do in the future.
ASCII.
Yeah. And then hit save. Hit class on the first upper. Yeah. Class. Yeah, and then save. Okay, and then go back to your orange box. Keep the orange box there. Okay, compile. Okay, now you go back to your Windows Explorer. the right hand side, Windows Explorer, not browser. Windows
This one?
Explorer. No, the file folder.
Oh, wait, that one.
Folder.
Yes.
And then hit this PC. Okay, Windows. And then it's an U, and then over there, go to the Blue Jay. Chapter 1, hit. Okay,
Oh.
now you use the open Readme. Okay, it actually will open that Readme file, but it's actually not aligned, right? Close this one. No, don't delete that. Wait. Close. You destroy it. Okay. Actually, you open the Readme with WordPad. No. Right hand side. Open with. After share, there's an open with WordPad. Okay. You see, this actually is the text file actually for you. Now why you actually you delete something, right?
No.
Yeah, okay, that's fine. Close this one. So let's just tell you that is a text file, right?
Yeah.
And then you have the frog.java, right? Open that with the open with the WordPad as well. Or you have a Notepad double plus. Open the with Notepad double plus. Yeah, open that one with that one. Okay, right? It's the same problem you can see over there, right? So, okay, close this one. So what I want to tell you is that whatever you did on the Blue Jay is can be accessed by what? By text editor, Notepad double plus or Notepad or WordPad. Is that okay?
Okay.
And then hit doc. Hit doc. No, not there. Hit the index, double click, and then open with Google Chrome. Google Chrome is fine. Okay. So this one you have your documentation page.
Okay.
Now go back to your browser. Choose your computer programming browser. No, go back to your browser. Yeah, the Trinter website. Okay. So now actually we are about to finish. It's 9 o'clock already. So your responsibility for this after this session, you need to read this chapter carefully. Okay. I'm just teaching you, but you have the responsibility to read it. Make sure you understand all of them. Is that okay?
Okay.
And then now you need to do exercise, pull down. It has 1, 2, 3. If you like, you can do all of them, or you can do odd number or even number, that's fine. But turn it before next meeting, okay?
Okay.
Is that okay?
Okay, so
do you have time to do it or no?
I can do it tomorrow. I can't do it today.
Yeah, I know, but do you have time? Next time, probably Wednesday night, can you finish that? Try, yeah, if you can finish all the 3, you can do all the 3. If you finish the odd number or even number, I'm okay.
I can finish all of it.
Yeah, just try, okay?
Okay, then.
Then we finish our chapter 1 right here. Is that okay?
Yeah.
Okay, thank you.
Thank you. Bye-bye.
Bye now.